Okay. Can you please tell me now if I'm properly audible? I think now I should be audible. Just confirm once and then we'll begin. Okay. Okay, great. Thank you, Sudhanshu. So let me share my screen. Okay, Manoj. Okay, Abhishek. Thank you. So I hope my screen is also visible now. Just confirm once it's visible properly. I think it's visible now. Is my screen properly visible? Hello. Hello. Okay, I think the screen is properly visible. So let's just quickly go through the first question. I think it was quite an easy question. There is no need to, go in very much depth. I'll just show you the submission for it. Okay. So when can we say whether a year is leap year or not? If the year number is divisible by 400, then it is leap year. Otherwise, if it is divisible by 4 and not divisible by 100, for example, let's say 24 or something like that, then that is also leap year. Obviously, we are currently in 2000 range, but just for an example, I gave 24. And in all the other cases, it will not be a leap year. Okay, so there will be only three conditions. So I think this is quite easy. There is no need to explain more in this. We'll move on to the next question. Please let me know in the comments. Shall we? Okay, great. So this was the second question in which an array of minimize the expression is the name. Given an array A of containing n numbers, find an integer x such that the sum of A of I minus x modulus square for all I between 0 to n minus 1 is minimum. Also, it is said that average of array A is an integer value. Okay. So basically, what is given in the question is see, we are given an array A which contains n elements. Okay, and we want to minimize this value summation I equals to 1 to n a of I minus x square and their summation. Okay, so we want to minimize this value. Okay, so what I can do is whenever I want to find the point of minima, I can differentiate this, okay, with respect to x, because x is a variable, right? So what I will get is here you can see and equate it equal to 0, right? So this will become what, 2 times summation I equals to 1 to n, um, or even if you make it like this, summation I equals to 1 to n 2 times a of I minus x, so this would be in general, and minus 1. Okay, this will be equal to 0. Now this 2 and minus 1 are constant. Okay, you can take it on the other side. So your equation becomes summation I equals to 1 to n a of I minus x must be equal to 0. So I can see, in order to find the point of minima, I differentiated this equation and equated it with 0. Okay, so now I can say that summation I equals to 1 to n a of I minus n times x must be equal to 0. Okay, I removed the summation sign and applied it only to a of I. Okay, so from here I can say my x will be equal to summation I equals to 1 to n a of I divided by n. Okay, so it is nothing but the x will be nothing but the average value of all the numbers. So you can just directly return the average value of you can just directly return the average values of all the n values in the array. Okay, and that would be the required x. Okay, also in the question it is said that the average value of a of I is an integer. Okay, so it is very much important it should be an integer, otherwise it will be a floating point number, and then there will be two choices, either the floor value or the cell value, one of them will give the minima. But we do not have to think about all of these conditions. Simply the average value of this would give the minima. Okay, so I'll show you the solution. So I have nothing but done the sum of all the values of a. So I've taken it in some variable and then finally written sum by n, and that would be the x value where the summation a of I minus x the whole square, this expression will be minimized. Is that clear? Shall we move on to the next question? Any doubts in this question? Please let me know. Hello, any doubts in this question? Okay, great. Let's move on to the next question. Shortest subarray with sum k. Okay. So what does this question say? Given an array A of integers and another number k, find the shortest subarray that has a sum at least k. If there is no such subarray, then return -1. Okay. So basically, in this question, third question, what they are saying is you have an array A. Okay, let's say in that there are n elements. Now you want to find the shortest subarray. Now what is the meaning of shortest subarray? Shortest means the number of elements in it should be minimum, and subarray means a continuous segment of the array. So we want to find the shortest subarray of array A, in which the sum of that subarray, okay, so sum of the elements of that subarray is at least k, so it is greater than equal to k. Okay, so for example, if we take the example which is given in the question, then n is 5, k is 3, n is 5, k is 3, and the array elements are 0, 0, 2, 1, 1. Okay, so I want to find a subarray, the shortest subarray whose sum value is at least 3. Okay, so now see, this subarray contains value of 4. Okay, that is also greater than equal to 3, but it contains 5 elements. Now if you look at this subarray, it contains 4 elements, its sum is 3. Okay, that is still greater than equal to 3. Even this subarray contains the value 3, the sum of the subarray is 3, and it has 3 elements. Now this subarray, which contains 2 elements, 2 and 1, it also has the sum of the subarray 3, which is greater than equal to k. Okay, because k is 3 and the size of this subarray is 2. Okay, now this is the shortest subarray. There is no subarray with elements less than this possible whose sum is greater than equal to k. So my answer for this question should be 2, and the output is 2. Okay, now here the expected time complexity and expected auxiliary space is big O of n. Okay, now see, the brute force approach would be what? If I look at the brute force approach, then the brute force approach would be to basically generate all subarrays or generate sum of all subarrays, which would basically take big O of n square time, and out of that, whenever I get the sum value greater than equal to k, I would compare the length of that subarray with my answer variable, and in my answer variable I would store the minimum length of any subarray whose sum is greater than equal to k. But that would result in a time complexity of big O of n square. So now we need to think of something more efficient. Okay, so what I can do here is I can use the two pointer approach. Okay, so I will be using two pointers. So what I will basically do is let's say at any given point of time. Okay, I am giving you a overview of a certain point of time, okay, at time t or at a step number t. Okay, then how will we start with step 0, that I will let you know. But at a certain point of time, let's say I'm looking at this sub array. Okay, and this is my L index, left index, and this is my R index, right index for that sub array. Now let's suppose the sum of this sub array is sum. Okay, so there can be two cases: either it is greater than equal to k, or if it is less than k. Now if it is less than k, then what I will do is I will try to increase the size of the sub array, because in order to find the shortest subarray whose sum is greater than equal to k, the sum should be greater than equal to k. Now the sum of this subarray is less than k. So I will increase the number of elements in this subarray so that its sum increases and goes above k. Okay, if possible. So what I will do is I will increase it from the right hand side. So now my starting index will be L and my ending index will become R plus 1. Okay, now again for the sum of this subarray there will be two cases: either it will be greater than equal to k, or it will be less than k. Okay, again if it is less than k, again I will increase the size by one element. I'll keep increasing the size from the right hand side. Okay, now if it is the other case, if the sum of this subarray is greater than equal to k, then what I will do is, first of all I will compare this length with my answer length. So answer is equal to minimum of answer comma R minus L plus 1, and then I will decrease this size of this subarray, because I want to find the shortest subarray or whose sum is greater than equal to k. So I have considered this subarray from L to R. Now I will decrease its size from the left hand side. So I will remove one element from that subarray from left hand side. So my subarray will remain how much? L plus 1 to R. Okay, I have removed one element. Now again I will check the sum of this subarray. Again if it is greater than equal to k, first of all I will compare R length of this subarray with my answer variable, and again decrease the size of the subarray. So whenever the subarray sum is greater than equal to k, we will compare the length with the answer variable and decrease the size of the subarray. Whenever the subarray sum is less than k, we will increase the size of the subarray and try to make the sum greater than equal to k. Now how will we start and how will we end? So we will start with L equals to R equals to 0. Okay, and we'll keep repeating this process. So if my sum is less than k, or at every step I'll whenever the sum is greater than equal to k, I'll keep incrementing L, and at every step, after every step, I'll increment my R by once. Okay, so you got the concept. Now let's look at the implementation so you get the better clarity. Okay, so see, what I have done is I have taken one answer variable in which I have stored -1. Okay, I have taken one sum variable in which I have stored initially 0 because no elements are considered. Then L equals to 0. Now I am running a for loop from R equals to 0 to N and R plus plus. Okay, 0 to N minus 1. And at every step, I'll include the array element at rth index to my sum. Okay. Now while sum is greater than equal to k, first of all I'll update the answer variable. So if answer equals to -1, so when it will be -1, if I have not found any subarray with sum greater than equal to k, okay, then answer will be equal to R minus L plus 1, the subarray which is under consideration right now. Else if my answer variable is not -1, then answer equals to mean of answer comma R minus L plus 1. Okay, and then I'll decrease the sub array from the left hand side. So while the sum is greater than equal to k, I'll keep removing the array elements from left hand side. So my new sum will become sum equals to sum minus a of L, and the new starting index will become L plus 1. So I'll basically do L plus plus. Okay, so by the time we come out of this while loop, my sum will again be less than k. Okay, and then again I'll add a new element from the right hand side. So in this way, I'll just keep on increasing or decreasing the size of the subarray, and I will store the shortest size subarray in my answer variable and finally return it. Now this will be completed in big O of n time. Okay, so how it will be completed in big O of n time? Because from outside it looks like there are two loops, one is the for loop outside and one is the while loop inside. But if you look, my r index will go from 0 to n minus 1 once, okay, and my l index will also go from 0 to n minus 1 at max once, okay. So basically, see, for I equals to 0 to n minus 1 and for j equals to 0 to n minus 1, if I write two for loops one inside the another like this, then the time complexity will be big O of n square. Why? Because for every index I, j is going from 0 to n minus 1. So for every index I am running a for loop of size n, and there are n values for I. So for n values of I am running a for loop of size n, and hence the time complexity becomes n square. But here it is not the same thing. So for example, let's say this is my subarray, this is L, this is R, okay. Now let's suppose the sum of this subarray is less than k, so I incremented the size of the subarray under consideration and I made it R plus 1. Now I will never encounter n subarray L plus 1 to R or L plus 2 to R or L plus 1 to R minus 1 and so on, right? These subarrays will be ignored and will never be encountered. So we are not generating all the subarrays here. Here basically two for loops are being done, one for L and one for R, okay? So the total time complexity will be big O of n. So any doubt in this question, please let me know, or shall we move on to the next question? Yes, please. Okay, great. So let's move on to the last question, that is minimum cost path. Okay, so let's not go through the question first. Let me just tell you the overview of the question. Okay, minimum cost path. So what does, okay, great. So what does this question say? In this, basically a matrix is given of size n cross m. Okay, there are n rows and m columns. Now what happens is you need to move from first column to last column. Okay, you can start from any row number. Okay, in the first column you can start with the first row, second row, third row, or any row. And in the last column also you can end at any row. There is no restriction on that. You can end at any row number, but the thing is you should start from the first column, end at the last column. Also, how you have to move, you have to move from first column to second column, from second column to third column, from third column to fourth column, and so on up till nth column. Now when you move from first column to second column, you can move in any row. Okay, you can move from any row to any row, from first column to second column. Okay, so for example, if let's say this is my 4 cross 4, or let's say 5 cross 4 matrix which is given to me, so I start from here, then from there I wish to go there, then from here I wish to come here, and from there I wish to come here. Okay, so this is totally fine. I went from first column to second column, from second to third, and from third to fourth. Okay, you can choose any row number, okay, when you move from a particular column to a particular column. That's not an issue. Now, this path which you took has a cost associated with it. So, how is the cost calculated here? It says that the cost is the difference between the max value and mean value which you encountered on your path. Okay, the difference between the max value and the mean value which you encountered on your path. So let's say you went here, then you went here, then you went here, and then you went here. Let's say the value here is 3, the value here is 8, the value here is let's say 2, and the value here is 5. So you have 3, 8, 2, and 5. So the maximum is 8 and minimum is 2. So the cost of this path is 6. Now you need to tell the minimum cost path among all the possible paths to move from first column to last column, keeping the constraints in mind. That is the question. First tell me, is the question understood? Is the question clear? Okay, great. So now see, let me give you a simpler version of this question first, and then we'll move on to the solution of this. Okay. Let's say I have given you an array of size n. Okay. I have given you an array of size n. And I ask you that pick a subset of k elements. Okay, pick a subset of k elements such that the difference between the max value among these k elements and the mean value among these k elements is as minimum as possible. Okay, so let's say your array is 3, 8, 2, 1, 5, 6, 3, 9. Okay, and I tell you that the value of k is 4. So you need to select a subset of size 4, or and such that the difference between the max value minus mean value is as little as possible. So how can you solve this question? See, here there is no, here you cannot say if the value of the elements will be small, this difference will be small, right? But the k elements which you will select will be in a continuous manner if you set them in the sorted order. Why? Let's say I sort these LA elements. Okay, so it becomes 1 2 3 3, 1 2 3 3, 5 6 8 9. Okay, these are the elements 5 6 8 9. Okay, so I will either choose these four elements. Why? Because let's say I choose 1 2 3 and 5. Now the difference between 5 and 1 is 4, whereas if I choose these four elements, that is 1 2 3 3, then the difference between 3 and 1 is how much? 2. So I will always choose a, in the sorted array, I will always choose the continuous k elements and see the difference between the first and last element. Okay, because the first element will be the minimum element for those k elements and last element will be the maximum element for those k elements. So here the difference is 2. Then I'll move on to the next k elements. Okay, so here the difference is 3. Then I'll move on to the next k elements. Here also the difference is 3. Again I'll move on to next k elements. Here the difference is 5. Again I'll move on to the next k elements. Here the difference is 4. The minimum among all these is 2. So this will be the subarray selected and the value will be 2. Okay, is this much clear? Now see, something similar we have to do here. Basically here we have a matrix of size n cross m, and if you look carefully, see, we will be at first column, then we'll go to second column, then we'll go to third column, then we'll go to fourth column, then we'll go to fifth column, and so on up till nth column, sorry, mth column. So the total number of elements in our path will be how much? M, right? Here the subarray was to be selected was of size k in this 1D version. Here the number of elements to be selected is m. The only other constraint is there should be one element from each column. Okay, so what I can basically do is I can store all these n cross m elements in an array or a vector and sort them. Now I will check the different subarrays which contains elements from all columns. Okay, I will only check for subarrays which contains elements from all columns. You look here. Here also we were seeing continuous subarrays of size k. We were trying to select this subset. Why? because there the difference between the maximum and the minimum element will be smallest. The answer will be there only in one of these subarray. So similarly, here also I'll see all the subarrays, and I will only see those subarrays in which values from all the columns are present. Okay, if a particular columns two values are there, then that's not an issue, but value from all the columns should be there. Now why that's not an issue? Because if I get a subarray in which I have values from all the columns, at least one value from all the columns, I just have to take the difference between the last value of that subarray and first value of that subarray. Because in center, let's say here I have three values from column number 3. This is also from column 3, this is also from column 3, and this is also from column 3. This is from column 2, this is from column 8. Okay, and there are other values also from column 1, 2, 4, 5, etc. I only see. So now in my path, whether I select this column or this column or this column is irrespective, because when I select this subarray, my answer for the path will be the difference between the maximum value and the minimum value. So in center, which column I chose is irrespective. So basically, I'll sort all the elements of this 2D array in, first of all, I'll store in an array or vector, then I'll sort them. Then for all the subarrays which contains values from all the columns, at least one value for all the columns, I will consider those subarrays. And for such subarrays, I will say my answer is equals to minimum of answer comma last value of that subarray minus first value of that subarray, because that is the cost of the path, the maximum minus minimum, right? Now how will I calculate that that elements from all the columns are present at least once? So basically, during the traversal in this array which contains all the n cross m elements, whenever I encounter an element and I add it to the subarray under consideration, I will see in which column it belongs to. Let's say it belongs to 4. Okay, so I will increment the count of 4. That in the current subarray which is under consideration, I have one more element which is from fourth column. Now, after incrementing the count of the fourth column, if this count becomes equals to 1, it means this is the only element from the fourth column. So what I will do is I will keep one unique variable in my hand, and I will say unique plus plus. What does unique tell me? It will tell me that in the subarray which is under consideration right now, from how many unique columns I have values. Okay, from how many unique columns I have values, and if the value of this unique is equals to m, then for that subarray I will update my answer variable. Okay, let's look at the implementation for better clarification. Okay, so I have taken, first of all, I have taken answer equals to 10 to the power 9, some variables I, j and s. I have taken one count variable of size m. So basically, count of I will tell me how many elements from the ith column are there in the present subarray which is under consideration, right? Unique will tell me from how many unique columns I have at least one value in the subarray which is under consideration right now. So first of all, I will mark the count of I equals to 0 for the complete array of size m. Then for all the elements, I will push their value inside the vector A. Now in vector A, I have taken pair. Okay, if you can see in line number 40, I have taken it pairwise. Why? Because along with the value, I also need to store the column number. So A dot pushback array of ij, that is the value of that cell, and along with that I have also pushed the column number. Okay, because that will help me to update the count and unique variables. Okay, whenever I will consider that element under consideration, then I have sorted this value, sorted this array. Okay, now I have taken under the subarray which is under consideration right now, the starting point of that will be stored in variable I, and the ending point of that subarray will be stored in variable j. Okay, and S is the total elements, which is n cross m. Okay, so I is equals to 0. So initially the starting point of the subarray under consideration will be 0, and the ending point will increase at each step. So for j equals to 0 to s, j plus plus. Okay, so jth element is taken under consideration. So I will say count of a of j dot second plus plus. What does a of j dot second tell me? That from which column that value belongs to. Okay, and its count I will increase. Now, if the count of a of j dot second is 1, it means that that column's value, we have only that value from that column. So the number of unique columns from which we have value under consideration has increased. So I will say unique plus plus. Okay. Now, while unique is equals to m, so until the number of unique columns from which there is at least one element under the subarray in the subarray under consideration right now, I can compare my answer variable with a of j dot first minus a of I dot first, because the present subarray is from I to j. Okay, are you getting my point? So a of j dot first will tell the maximum value on that path, and a of I dot first will tell the minimum value on that path, because I is the starting point of the subarray, j is the ending point of the subarray, and the array is sorted. Okay, now I will remove the element from the ith side. Okay, because now see, I want to take values from, see, I'll tell you why I am removing an element from the ith side. Let's say this is the sub array under consideration right now. This is ith index and this is jth index. Okay, let's say there are total 5 columns. So let's say the last value which we inserted was from column 5, then the value before that was from column 3, the value before that was from column 1, the value before that was from, let's say, column 4, the value before that was, let's say, from column 2, and the first value, let's say, is from column 1, and this value is from column 2. Okay, now you can see there are multiple values from the same column. Why? Because until we did not found at least one value from each column, we were increasing the size of the subarray. Now we have one value from all the 5 columns, right? So we compared this value and this value. Okay, these are not values, I am telling from which column it belongs to. Okay, but now I also need to check for this subarray, because it also contains values from all the 5 columns, 4, 2, 4, 1, 3, 5. And in fact, the difference between the value year and year will be less than the difference between value year and year, because the array is sorted. Okay, then I can also compare the first and last values difference from this subarray, because this also contains one element from all the 5 columns, right? So we need to consider those cases also. So what I'll do, I'll remove the ith element. Okay, so when I remove the ith element from the current consideration, I have to decrement the count of that index where the ith element belongs to. Okay, so count of a of I dot second minus minus. Okay, so a of I dot second tells the column number from where that value was taken. So I'll do that minus minus. Also, if the count of that value becomes 0, it means now from that column I have no value under consideration. So the number of unique columns from which there is at least one value in the subarray under consideration becomes one less. So I will say unique minus minus. Okay, and then I'll increment the I index. So I'll keep repeating this while loop until the size of the subarray is until the unique value is m. There is at least one value from each of the column, okay, under consideration. And in this way we will find the minimum cost path, that is the minimum difference between maximum value and minimum value of any path taken. Okay, is this clear? Please let me know. That's why I told you the simpler version before, because after understanding that you will have a better idea of what we are actually doing here rather than directly coming here. Is this clear? Please let me know. Any doubts? Hello, please let me know in the comments whether it's clear or not. Hello, is it clear? Please let me know. At least one person. Please reply. If there is any doubt, I'll explain it again. Okay, so if there is no doubt, then I think we can end the stream here. Can you explain once more? Okay. So is the question clear? Okay, great. One more thing, please let me know if this question, which I told a simpler version of this, was that clear? Okay, great. So, see, let me take the example. Okay, so it is 1 2 3 1 2 3 and 2 1 1. Okay, so hello, no, okay, hi Palash. Okay, so that is also not clear. Okay, no problem. So see, if the question is clear, uh, see, our path will contain m elements, right? Because we are moving from first column to second column, from second column to third column. We can move on any row number. Okay, there is no restriction on that. From third column to fourth column, from fourth column to fifth column, and so on up till the mth column. Okay, so there will be m elements in our path. Okay, now I'll tell you a simpler version of this question. For example, let's say you have an array which contains n elements, okay, an array A. If I ask you to pick k elements such that the difference between the maximum value of those k elements and the minimum value of those k elements is as minimum as possible, okay, this is the question. Our question is also quite similar. We are given a n cross m matrix out of which we have to pick m elements. Why m elements? Because our path will contain m elements, and we need to pick these m elements such that the difference between the max element minus the mean element, that is the cost of the path, is as minimum as possible. One more condition which we have in this question is that there should be one element from each column, okay, which is not there in 1D example. Now, if I take one example from this, okay, you have n elements in the array A, and you have to select a subset of size k, okay. So let's say you this is the given array 2 8 6 4 1 5 9, okay, and let's say your k is equals to 3. So you have to select three elements such that the difference between the maximum and minimum element is as minimum as possible. So whenever you, whatever this answer be of three elements, this subset, if you arrange the elements in the sorted order, these three elements will always be together. Why? For example, if I sort this array, then it will become 1 2 4 5 6 8 and 9, right? 1 2 4 5 6 8 and 9, okay. Now if I take 1, 2, and 6, does it make any sense? Because 6 minus 1 is 5. I should take 1, 2, and 4 because the difference between the minimum and maximum element will be less. Here it will be 3. So what I'll do is, Okay, so Palas is asking, I am in my final year when the company is hiring people, when the recession will end. Yeah, I cannot say when the recession will end, but what I can see is that things have improved as compared to last year, or you can say beginning of 2023. Okay, that was even bad than this. At least now we see some companies hiring. Okay, so if so what I'll do is I'll check all the subarray of size 3 of continuous. I'll see all the subarrays of size 3. Okay, so I'll check and among that only one of them will be my answer. So the difference between the maximum and minimum element here is 3. Now if I check at this subarray, the difference between the maximum and minimum element is again 3. If I check in this subarray, the difference between the maximum and minimum element in the subarray is 2. In this subarray the difference is 3, and in this subarray the difference is 3. Okay, so the minimum value is 2. So the subset which you could have selected was of the elements 4, 5 and 6. Are you getting my point? Now if I come back to our question, in that we have n cross m elements, right? We need to select m elements because our path will contain m elements. We need to select such that the difference between the maximum element and the minimum elements among the m elements which we selected is as minimum as possible, because that is our cost path. It is defined in that way, right? Now if I look at this question in the similar way as the above question, so what I do is I store this n cross m elements in one array A. Okay, and now for all the sub arrays, one more condition which is there in our question is what? As compared to the 1D question, the simple question, there is one more condition in our question. What is that? There should be one element from each column. Okay, so what I will do is I will store all these n cross m elements in one array A. I will sort this array. Okay, so we are currently at this position. Okay, we have a sorted array. Okay, now among this sorted array I will consider all the sub arrays which contains elements from all columns. Okay, at least one element from all columns. Okay, so let's say there is one, let's say the total number of columns is 5. Okay, so let's say there is one sub array in which the first element is from first column, the second element is from fourth column, the third element is from third column, the fourth element is from second column, the fifth element is again from first column, the sixth element is again from fourth column, and the last element is, let's say, from fifth column. Okay, now since m is 5, see, I will consider this subarray and see that there is at least one element from all the columns. Okay, so what can be my different paths? This is first column, this is second column, this is third column, this is fourth column, and this is fifth column. This can be one of the possible paths, right? These are the values which I inserted in array A in sorted order, right? But if I look at the path on the matrix, this could be one path. Another path could be, this is my first column, this is the second column, this is the third column, the fourth column, and the fifth column. That is also possible, right? So for all the subarrays which contains elements from all the 5 columns, I will compare the first and last values difference with my answer variable, as we did in the simpler version. Okay, in this simpler version also we compared all the three size subarrays. Here the restriction is that there should be at least one value from each column. Now tell me, if I am looking at this subarray, so the maximum value on the path is from fifth column and the minimum value from the path is from first column. Now during the fourth column, whether I selected this value or this value is of no use to us. Okay, so I will simply see the difference of this and compare it with my answer variable. Okay, then I will move on to this. Okay, this subarray also contains at least one value from all the columns, and so on. I'll keep repeating. Okay, so that is what I have done here. So I have taken one vector A in which I will store all the n cross m elements, and I have taken it pairwise. Why? Because along with the value, I also want from which column it belongs to. Okay. Then I have taken one answer variable in which the value is 10 ki power 9 and some variables. Then I have taken one count array which contains m elements. Okay. Now, what will this count element tell me? Whenever I am adding a particular value in the consideration of current subarray, I will see its column value, from which column it belongs to in the original matrix. Okay, so that columns count I will increase, that from this column one more value is counted. Okay, and unique variable will contain the number of unique columns from which there are values in the subarray under consideration right now. Okay, so first of all, I have made all the count values as zeros. Then I have inserted all the values n cross m in my array A, and along with that, I have inserted the column number and I have sorted them. Okay, so I have sorted them. Now the subarray under consideration right now is from index I to j. Okay, so initially the starting index I have set I equals to 0, and S contains the total number of elements. Okay, n cross m. Now at every step I will increase the size of the subarray from right hand side, so my j will increase. So I will include the element at the jth index in my current subarray. So count of a of j dot second plus plus a of j dot second tells the column number from where that value came from. Okay, now if the count of that column becomes 1, it means that is the only value from that column, so the number of unique column increases. So I will say unique plus plus. Now, while the count of unique column is equals to m, it means that in the current subarray under consideration, there are values from each and every column. I have got a complete path. If there are values from m minus 1 column, let's say, then that is not a complete path. Okay, from that I cannot form a complete path. Okay, so while unique is equals to m, answer, first of all, I'll compare the answer variable. So answer is equals to minimum of answer, comma. Now that subarray starts from I and ends at j. So the maximum value is a of j dot first and minimum value is a of I dot first. So their difference will be stored in my answer variable. Then I will say count of a of I dot second minus minus. Okay, so what does that do? Now I am decreasing the subarray size from left hand side. Why? Because let's say this subarray one which contains values from first column, fourth column, third column, second column, first column, fourth column, and fifth column. Okay, this has values from all the 5 columns. But consider this subarray which contains values from third column, second column, first column, fourth column, and fifth column. It also contains values from all the 5 columns. Now tell me the difference between this value and this value, and the difference between this value and this value, which will be less? Obviously this will be less because the array is sorted in order. So the difference between this value and this value will be less. So that's why now when I get values from all the columns, I decrease the size of the subarray from left hand side. Okay, so in that way I increase the size of the subarray under consideration and decrease the size of the subarray under consideration as and when required. Okay, so I decrease the element, I remove the element on the ith index, and if the count of that column becomes equals to 0, it means there is no element from that column right now with me. So I'll say unique minus minus. Okay, and my starting index will become I plus plus, and this will repeat until unique is equals to m. And in this way I'll get the minimum difference uh, possible between among all the possible paths. Okay, I hope now it's clear. Okay, so all the 4 questions were discussed. I hope you people have understood, and I think we can end the session here. Okay, so we'll end the session here. Thank you, people, for joining. Good night.